Alright, this relates to exponentials and logarithms because I want to show you how they come up. It can be tiring working through all these exercises on logarithms and exponentials without seeing the big picture. This is still a small picture, but if you want to discuss how an object falls when there is air resistance, let's run through the setup of that. So we're going to use Newton's second law. The sum of the forces in the x direction is 0. There's no wind or anything. The sum of the forces in the y direction are not 0. So that's m, second derivative of y with respect to t. This is acceleration in the y direction. And important phone call, I hope. Nope. And what's this equal to? Well, we have some forces here. We have a minus g, mg actually. Whoops, minus mg, and we also have a minus cv. The minus sign is there because it opposes the direction of velocity. So these are the components in the y direction. So now we can go ahead and start working on this. The first thing we're going to do is convert this to the derivative of velocity. Right? Acceleration is the derivative of velocity, and we could put a subscript y here, but we're not going to need it. So we're going to have the m times dv dt equals minus gm minus cv. It's another differential equation. Physics and engineering are full of these, and even though you don't know how to solve them yet, it shouldn't prevent us from taking a look at them. Now we can divide by m here, simplify things. Let's go over here. So we're going to have dv dt equals minus g minus c over mv. Now the next step is a step you're not going to understand yet, maybe not for a few more years, but I'll let you know when you're not supposed to understand, and then I'll let you know when you should. This next thing is called separation of variables, and it's a technique you'll eventually learn in differential equations. It breaks up the derivative. It's kind of neat. I'm going to pull a minus sign out of this. Put a dt there. And then I'm going to divide by some stuff. And why I'm doing this isn't going to be clear yet. But I want to show you why all this. Why do you have to learn all this other stuff? Well, it's because eventually you're going to do stuff like this. You're going to take a differential equation and convert it into a couple of integrals. Now this integral, of course, is pretty easy to do. This is minus t plus, say, some constant d. This one over here, though, takes a bit of thinking. And what you should be able to figure out, noticing it's dv, so v is the variable of integration, is this is going to be a logarithm. You may want to take some time and verify that. So this logarithm is the absolute value. Whenever we integrate something like this, we get a logarithm of the absolute value. But this isn't all that it is. If you were to check this, the chain rule would spit out the c over m. So I need an m over c in front. So right here, what happened is there's a little bit of chain rule. Or if you want, you could do this with u sub. All right. There's that logarithm coming up. Now what happens next? Well, I want to solve for v. I want an equation for v. So if I multiply both sides by cm, I have ln, absolute value, g plus c over m, v, equals, I'll have minus c over m, t, plus d. Wait, did I forget to multiply? No. It's an arbitrary constant. So c over md is also arbitrary. So you'll see this a lot of times in books and stuff. D could represent anything. If it's anything, something times anything is still anything. It simplifies it. And there's that logarithm. Okay, now I'm going to exponentiate both sides. This is something you may have had to do in an algebra class. And this is why you had to do it. This is what it's building up to. There's that exponential, right? Now we can break this up a little bit. I hope what you're seeing here are all these different algebraic properties that you've had to learn. I sound like a smoker. So I've split things up, right? If you have an exponent with the sum, it's the product of bases. Now, this is positive, and it's arbitrary. All right. I can pull the absolute values off this, g plus c over mv, and I'll get a plus or minus e to the d. Think of the time in algebra where you had to use absolute values. Here it is. This is why. Now this is an arbitrary non-zero number. You can't get 0 out of this. But if this were 0, you'd have a different situation. It's best left to differential equations. There are some little things here you have to be careful about. But this doesn't concern us here. Again, the only part here you should really not understand is this separation of variables I did up here. Right? So going from here to here is a bit mysterious, but you should be able to do the integration. All right. So keep solving. This is all the algebra stuff. Oh, we're also going to replace this with a. Call it a. So then we have g plus c over m, v equals a, e to the c over mt. Let's keep solving. We're going to move things around. G minus a, e to the minus c over mt equals c over mv. Multiply some stuff. Get an mg over c minus, and this is arbitrary. Multiplying, it's still arbitrary. So if you have m over ca is still arbitrary. You could keep all these letters. It would be fine. It's just not necessary. Whoops. It's not very high tech. Sorry. All right. This equals v. Now, what is this crazy a thing? Well, I should have specified an initial condition. What is the velocity? Let's suppose it's 0. That is, suppose we're in an airplane and we jump out. And ignoring our horizontal velocity, our downward velocity is 0 initially. So let's use that. So v of 0 is 0 equals mg over c minus a e to the 0 is mg over c minus a equals 0. So a equals mg over c. Also note that you could figure this out a little bit ahead of time. A has to have the same units as mg over c, because this is unitless. The exponential is not unitless. That is, well, actually, this is also unitless. So this is unitless. So you could check your work. C over m must have units of 1 over time. And so, A must have units of mg over c. You can figure out what this is supposed to be, in fact. Let's go back a second. What are the units on c? Where is c? There's c. If I go back here. Well, if c, v are newtons, those are kilogram meters per second squared. Well, velocity is meters per second squared, so c must have units of kilograms per second. Right? So if we go back down here, actually, if you have kilograms per second over kilograms, whoops, sorry, if you have kilograms per second over kilograms, then you have 1 over seconds. And likewise, mg has units of newtons, right? And then c has units of kilograms per second. So this is kilograms meters per second squared over kilograms per second. This is going to give you meters per squared. So we know this is going to be some sort of speed or velocity. And a has to have the same units. So this is going to be a speed as well. All right. All right, let's finish this problem out. So v of t is mg over c minus mg over c e to the minus c over mt. We can factor. Remember when you learned to factor? Well, this is why you need it. Right. This describes what happens. Now let's check it. What happens as t gets big? All right. Well, as t gets big, this goes to 0 as t goes to infinity. So the limit of this equation is mg over c. And this is called terminal velocity. So where did this come from? Well, this came from physics and calculus. This is the equation. You can even sketch a graph for this. You know, when t is equal to 0 initially, you'll have initial velocity of 0. That's what we start out with here. All right. And then this exponential is a decaying exponential, right? Goes down like this. With the minus sign, it flips upside down. The plus 1 shifts it up, and you scale it. So you probably had to spend a bunch of time, and maybe you're still spending a bunch of time, sketching graphs. And that probably seems really annoying, because you just have a graphing calculator. I'm putting a dotted line here because it doesn't matter. The reason why you need to be able to sketch graphs without a calculator is that when you start doing real physics and engineering, you won't have numbers quite a bit of the time. I don't need a calculator to graph this, and a calculator can't graph this. I can graph this, though, because I understand what decaying exponentials look like, or just what an exponential looks like when I flip it around the y-axis, then I flip it around the x-axis, then I shift it, and then I scale it. So this is the graph of v, and this is its horizontal asymptote. So if you look at this whole video, you know, ln came up, e to the t came up, horizontal asymptote came up, absolute value came up, factoring came up, properties of exponents came up, integration, differentiation, Newton's second law came up, a limit came up. This is the way that engineering and physics tends to happen. All the things that you're learning now culminate into if you pardon my French, a shitstorm of mathematics, where you're using essentially everything you know constantly in every problem. So, hope this gives you a bit of an idea of where some of these things pop up.